So let me formally introduce myself. My name is Jason Erdreich. I'm a technology and engineering educator, and I'm working with the Autodesk and Tinkercad and Instructables team here to do webinars like this and just provide some really great resources to teachers like you, which I'm super excited about. And I'm joined by my co-host, Randy. Do you want to
Hi,
say?
I'm Randy. I'm the co-host. I am on the education team here at not Tinkercad, Autodesk, and I work primarily on Tinkercad and Instructables and a little bit on Fusion.
Yeah, yeah. And you can see that we also have Nicole. I don't know if you can see Nicole, but we have Nicole here, and we're probably going to have some more Autodesk team members join us. So the Autodesk team is working to not only help things like this webinar happen, but they'll also be working with us throughout the webinar in the chat to help answer your questions. So big shout out to Nicole and, of course, all the other Autodesk team members that help make this thing happen, which is great. So, welcome to our first Level Up of Fusion in Secondary Education webinar for this year. So this is a series that we decided to launch after some feedback that we got with some more folks looking to learn more about how to use Fusion 360 and these types of skills in their secondary education classroom. So we're going to be running these webinars every other Thursday between now and through, let's say, January or so. We have a number of webinars scheduled on the webinar page, so you can see all the upcoming events that we have. And if you're familiar with the Teaching with Tinkercad webinar series, that will return as well in the new year. So in the new year, we're going to have a new schedule out that's going to allow folks to attend either or both the Level Up series and also the Tinkercad series, whichever suits your needs the most. So definitely stay tuned. Keep in touch with the webinars page. And of course, if you're looking to learn more about Fusion 360 specifically in education, you can, of course, attend or visit the education page for Fusion 360. And I want to point out a couple things. First, our next Level Up webinar is going to be in 2 weeks, same place, same time. That's going to be called Design Multi-Part Assemblies. So we're going to dive deeper into the different construction, assembly, even some of the simulation features built into Fusion 360, which is super great. Tonight is all about 3D printing better, which we'll talk obviously about. And I want to just point out that not only is this webinar being recorded, or we're going to share the recording on our YouTube channel, but we're also going to be sharing these slides. So everyone who's attending this webinar live will have access to these slides. So you can see that many things are hyperlinked, which means that you'll be able to go back through, click through all these links, and we're also going to share a bunch of other resources, which we'll talk more about as the webinar goes on. So we already asked you to introduce yourself briefly, but we're going to launch a poll right now. And the poll is going to gauge your experience with Fusion 360, whether you've taught with it before, whether you're just getting started. So we should be launching that any moment. So you should see that on your screen. And just go ahead and describe what your experience with Fusion 360 would be. Have you used it at all? Have you tried it once or twice? Are you an expert? Are you just trying to learn a little bit more? This is going to help kind of cater and gauge our conversations a little bit. It'll help me kind of determine the best way to approach things. So I'm seeing a lot of folks just getting started, maybe not even a little bit or just starting a bit. Some folks who maybe have used it for some projects and things. So that's awesome. You are all definitely in the right spot because we're going to be talking, of course, about 3D printing, but also getting started with Fusion 360 as well. So thank you for taking a moment to answer that. I see most of us have tried it maybe a couple times, but definitely room to expand our knowledge, which is great. And that's, of course, the goal of this whole Level Up with Fusion series, not just tonight, but all the webinars we have planned over the coming months. So how to participate? As you can see, we have a chat, which is pretty active. You can use the chat the whole time. And as I mentioned, I have a number of Autodesk team members with me who are going to be answering things and posting links in the chat. Oops. But there's also a Q&A button as well. The Q&A button's super helpful because it doesn't go very fast. So the chat's going to scroll really quickly. If you ask a question, it'll stay there and then we'll answer it and then everyone can kind of go back and check out the answered questions. So the best way to participate throughout this webinar, if I mention something, if you have a follow-up question, drop it in the Q&A. And then there's also going to be a dedicated Q&A session at the end. We'll make sure you can see our faces. We'll answer your questions live, and we'll go through a recap of everything that we cover. And again, as I mentioned, this webinar is recorded, and we're going to follow up with the slides that you see as well. So the first thing I want to cover, because we do have quite a few folks who are new to Fusion, is what is Fusion 360, right? So first off, it's it's many programs kind of integrate into one. So if you've worked with Tinkercad before, you might know that there's 3D designs, circuits, SimLab, and code blocks. Well, Fusion is similar in that there are a lot of different ways for you to engage and design. So there's a 3D design and modeling, which is where we can make 3D things, and that's where we're going to spend most of our time in tonight's webinar. There's also a manufacturing where you can prepare your designs to be creating things, whether it's 3D printing, working with the CNC. We're going to be spending some time with that tonight as well. But you can also design electronics like printed circuit boards. You can simulate to see how parts might interact or what stress they can handle, how much would it take to break a part. You can use generative design, which is allowing Fusion to actually help you make effective designs. And there's lots of opportunities for you to collaborate, share designs, share documents, things like that. So we're going to be covering a couple of these features in tonight's webinar, but there's certainly many more things that we're going to be talking about in the Level Up with Fusion series over the coming weeks. Now, why would you might consider using Fusion in your classes? And that's really because it allows your students to experience real-world product design and creation, right? So Fusion mimics all of the professional and industrial type programs that are across the Autodesk suite, and this is also used by many businesses as they're designing real-world products. So if you bring Fusion into your classroom, students can really experience the design process, the design cycle to make a real-world product from start to finish, whether that's a sketch, a model, manufacturing it using some type of production technique, even creating circuit boards or electronics and animations and renderings and so much more. So it really allows your students to approach and experience what it might be like to be an actual designer, product engineer, manufacturer, whatever it might be. And that's really exciting for students to get these skills and hands-on with it. And we'll, of course, be talking about lots of great resources to help you get started with those topics in your class throughout this night and throughout the whole series. A couple great questions that I see that I think I'm about to answer. So first off, Fusion can be accessed in the browser, just like Tinkercad. So you can use it on virtually any device and also on the desktop. So if you download it for a Windows or Apple computer, you can use Fusion on the desktop as well. So two different ways to actually access Fusion. Educators and students also have access to Fusion for free. So you do need to create an Autodesk account, which is free to make. And depending on your region, students have a certain age requirement. So for example, it's 13 in the United States, but that's going to vary a little bit depending on where you are in order to make this free account. But you do not need to pay for Fusion to have access. You have access through these educator accounts or student accounts that you can create. There's also Fusion 360 Teams. So I saw a question pop up about creating classes, like in Tinkercad. It's called Teams in Fusion. So you can create a team, which you might call your class, or you might call it period 1 or period 2. And you can share projects. Students can work in groups. They can share their Fusion documents from one to the other. You as the teacher have access to seeing everything. So if a student creates something and if it's within your team, you can see that. So you have access to your students' documents, and it's a great way for them to collaborate, and it actually reflects a business model. So for example, if I was working in a company, I'd create a team between my colleagues in my company. So it reflects that as well. So a little bit different to Tinkercad class, like somebody asked the question, but a very similar outcome and what it allows you to do as a teacher to help your students with their documents in Fusion. There's also limitless ways to customize Fusion 360. So as I mentioned, there's a lot of different apps and a lot of different things you can do in Fusion, and everything's very customizable. And the first thing I recommend folks do when they come from Tinkercad is customize their preferences. And I have this linked from the Tinkercad blog. But if you've used Fusion, I saw on the poll, some people maybe use it for one thing or the other. You might have initially, if you come from Tinkercad, be unfamiliar with the mouse, the way that the buttons work. You can actually change Fusion 360's preferences to mimic how you can click and scroll and navigate just like you do in Tinkercad. And if you are bringing your students from Tinkercad to Fusion, that's definitely something you want to consider because it'll just make Fusion far more comfortable for them to approach. And even more so, all the menus are customizable. So you'll see me working in Fusion, and you might notice that some of my icons are in a different spot than your icons. It's just because I've sort of built my own preferences and things as I've designed my own Fusion workspace. And I'll definitely make sure I take a moment to show you how to customize this when I dive into Fusion for tonight's webinar. So tonight's webinar is all about 3D print better, right? And before we dive in, I think it's really important that I just define factors for determining 3D printing success, right? Because obviously 3D printing is a very, very big environment, right? There's lots of different types of things you can do, lots of different types of 3D printers out there. So if I say 3D print better, how do we actually know it's better, right? So what am I using to determine that, right? And there's a couple factors. First off, can we make parts that are smoother of a higher detail, right? And that's a big reason that you might want to consider just taking your things from Tinkercad into Fusion, as I'll show you in a moment. Also, 3D printing parts that are stronger, more difficult to break, right? How can we design things to handle a high level of stress or a high level of load if I wanted to make a bracket? Also, 3D printing multi-parts. What if I want to make something that's complex, very geometrically challenging? How can I do that smoothly or effectively? How do I combine different models, right? What if I want to take a model from one place and manipulate it and combine it with something else? How could I actually 3D print things more quickly or more effectively? And most importantly, how can we go through an iterative process? So how can I go from design to testing to evaluating to manufacturing to redesigning like a real engineer might do, like a product designer might do, all in one inclusive space? And that, of course, is one of the biggest features that we're going to be using from Fusion is the fact that it's all kind of included in one space as we work through 3D printing. But I want to take a second just to remind you that 3D printing is a massively diverse field, right? There are endless different 3D printer brands. There's different types of 3D printers from fusion extrusion types, right? So you have your deposition modeling or your filament fusion type. You might have a laser, like a liquid stereolithography SLA type printer or a powder printer or a metal printer, right? There are so many different types of 3D printers out there. And we can't really dive deep into the nitty gritty details for each one. But there are strategies for designing just good practices, making models that are just good practice models that would be suitable for a lot of different 3D printing environments. And that's what we're going to really focus on tonight. So it's going to be best practices, tips and strategies for implementing these practices in your classroom that would work on a very wide range of 3D printers. But towards the end, and actually even in the beginning, I'll show you some models and things from my own printers, which might be similar to the ones that you have. They'll help us kind of facilitate the conversations. So that said, the first thing I want to talk about is just designing in Fusion 360. And let's just talk real quick about Fusion 360 versus Tinkercad, right? Why might you want to transition from one to the other? So I'm going to change my screen share so you can see this, which is a coffee mug, which is my personal favorite first project to do in Tinkercad. A, because I enjoy my coffee, and B, it's a real world product that students can design and create. And we can see that this coffee mug is made from multiple parts, right? So if I double click, you can see I have a couple different cylinders, and I think my torus shape here, or my rounded, is that called a torus? It is, shape as I design. But you'll also notice that there are kind of like ridges and sides. And yes, I can change the sides of my cylinder, right? So I can make it smoother and I can add sides. But even if I go all the way up to 64 sides, you can see that there are still kind of ridges. It's not that smooth. And of course, with my other shapes, I still see this. One thing that you can do from Tinkercad is use the export or send to button just to take your design right to Fusion 360. And you can actually, if you have an account set up, you can actually add things directly to a team. So I mentioned teams earlier. So if I was part of a team, let's say I was part of a class, which this account isn't, I can actually send that right to that team, which is super cool. And you'll notice immediately after bringing your design into Fusion 360, which is what you should be seeing now, it becomes smooth. And that's because this is created into a solid shape. So it kind of takes your design, brings it into the Fusion geometry, and we can see that it's smoothed over, right? So look at how smooth this torus is. So that's automatically going to kind of increase the quality of your designs. And you're going to see this if you 3D print it. So I'm going to stop the share briefly, only because I need full screen to do this. And hopefully my Zoom background lets me. All right, there we go. I got to find the right angle. This is my Tinkercad mug, and you can see all those different sides in the 3D print, even in the torus. You can see those bevels. But my Fusion one, sorry for my Zoom, very smooth. Very, very smooth, right? So that's automatically, I didn't do anything in Fusion other than import it. And that automatically took my model, and I apologize for my invisible zoom there. It took my model and it enhanced it just right away by bringing our designs into Fusion. So that's automatically one way to improve your 3D print quality by using Fusion 360, which is excellent. Let me just bring Fusion 360 back so we can continue our Fusion 360 conversations to more things. Another big thing that's really important to consider are tolerances with your design, right? So what I mean by tolerances is I'm going to switch to this, which is a box, okay? And I want to create a lid that slides in this box. So this is going to be a box with a nice sliding lid, right? Now, if I were to make my lid fit from here to here, corner to corner, it might be so rigid that it's not actually going to slide. And the reason is A, we need to give ourselves some wiggle room in general for moving mechanisms, but also as you 3D print, it tends that your filament might change shape. When it goes through thermal properties, it usually shrinks, tends to shrink a little bit, right? So you might need to add tolerances. And this tolerance, this buffer is going to change a little bit. So what I mean by that is you might be working with one type of printer that's higher quality versus a printer that's lower quality. The lower quality printer might need more tolerance. You might need to give yourself more wiggle room. Something else that might change is the type of filament. So I often print in my classroom with PLA filament. It's usually referred to as the most safe filament you can use in schools. And that has a completely different tolerance than, say, ABS, which prints at very different temperatures, right? I also sometimes find that the tolerances are going to vary depending on the orientation, meaning that if my part's printed horizontally like this versus vertically, oh, sorry, I'm not trying to make you dizzy, vertically like this, the tolerances might vary a little bit. And I lost my box. There we go. So in general, a good practice for tolerances is usually half a millimeter. I find to just be a good general starting point. Adding half a millimeter of space is usually a good practice when working in typical settings for PLA if you want a nice loose fit whenever I work with my students. So if I actually want them to make a hinge, if I want them to make a lid for a box like this, I usually have them add half a millimeter of buffer. For my folks in the States, that would be like 0.2 inches or so, or 0.02 inches. Hang on, let me give you I always do it in millimeters, but let me give you the accurate conversion for my international folks. Uh, 0.02 inches. Sorry, that's what I thought. 0.02 inches, or half a millimeter is a little bit simpler to say. So here's what I mean by that. I'm going to make my lid for my box. So I'm going to make a new sketch on the front of my box. And I'm just going to use this offset tool to offset a shape within. So you can see this red line is what I'm offsetting. And I'm going to make my offset distance 0.5 millimeters, like this. So I know that the dark blue is a little hard to see, but we can see that this line is drawn half a millimeter away on all sides within my box. And then to finish my lid off, I just need to draw a line that would connect like so. And then I'm going to extrude this lid shape until it hits this back wall and make sure that it's not the same part. So instead of saying join, which would make it a solid part, I'm going to say new. And that gives me this lid. And we can see under the bodies, which are my parts, I have a lid, I have a box, and I have my tolerance added right there. But again, I need to be super clear. Half a millimeter might not be optimal in your printing conditions with your model printer. It's just a good place to start. The bigger the tolerance, the easier it will be to fit together. But of course, if you're looking for a more snug fit or whatever it is, you can kind of experiment and trial and error as you go. I also just want to point out that we might want to consider part orientation. And what I mean by that is if I were to actually 3D print this, I wouldn't want to 3D print this box with the lid just like that. Because realistically, if I tried to put supports or if I tried to actually do this, the lid's probably going to be fused with my box. So what I would actually want to do after designing it is take my lid and move it like this next to my box. And now I'm printing on this nice flat surface. I'm printing with my box like so, with the opening facing up. And that's going to allow me to get a much more effective and stronger print. And I could even print it in two separate colors on two different prints or whatever it might be, just like so. Now, to kind of talk more about what I'm mentioning here with part orientation, I'm just going to make a really simple bracket. And I also know that some of you are completely new to Fusion, so I just want to run through some basic designs here. So what I did was I just made a sketch, which is how you usually want to start your designs. And I can use a series of tools. And as I mentioned, this is a customizable toolbar. So I can see some of the default tools, but if I browse my Create library, you can see that there are many different shapes. And if you find that you use one frequently, like let's say, for example, you use the 3-point arc all the time, you can actually pin it. So that way you can change which buttons you see. And I always recommend that teachers start introducing Fusion by building a toolbar that you kind of find to be the most supportive to your students, their needs. So I'm going to use the rectangle tool to draw a rectangle, and I can use the dimension tool to set dimensions, and I am working in millimeters, but you can set your document to be whatever unit you'd like to work in. And I'm just going to make a really simple bracket here. And I just started to design it in a good way, but I want to intentionally design it in a bad way to make a point. So we're going to just make a nice little bracket. Perhaps I need to support something, whatever it might be. Uh, cool. Bracket. Okay. I'm going to extrude my shapes. And if you're coming from Tinkercad, this is the biggest difference, is that in Fusion, you start with a 2D sketch and turn it into a 3D shape, where in Tinkercad, you might actually start with a 3D shape that kind of sort of looks like this. And while that does add a couple steps per se, it also opens up limitless possibilities as you're creating. And of course, we're going to dive way deeper into these types of concepts in all of our Fusion webinars to come. I'll make my bracket slightly more complex just by adding a couple holes here, as if I was actually going to perhaps mount something to this with my dimensions, whatever it might be. And then I'm going to, again, use the extrude tool to cut these through. Right. Now, so I have my bracket. Very, very simple. I would not actually want to 3D print the part like this. And the reason is, if I were to 3D print it like so, this bottom area is open. And I would try to be 3D printing in thin air. And while there are some really cool videos online about people doing this, it's not the most effective way to 3D print. What you have to do in this environment is add what's called support material, which can be peeled away. And I'm just going to, again, stop my share briefly to show you. I have my mug. Again, let me try my zoom background. You can see that this handle is floating, right, in midair. So I added this support material right here. And that way, it doesn't just cave in on itself. And support material can just be ripped off, but it doesn't leave the most clean finish. And for younger students, that could be a little bit more challenging. They might need to use pliers or something like that to get a really nice finish. So the best thing to do is after we design our parts, if I bring back Fusion, just consider print orientation. So even if I design my part like this, I might actually want to 3D print it like that, which just makes sure that my flat edges are touching the build plate, reducing the need for support material. Something else you might want to consider doing, which I know is a common thing that people ask from Tinkercad, is you might want to add fillets or chamfers, right? So this very sharp angle right here could be prone to cracking, right? Let's imagine that I'm using a typical FFF, fused filament fabrication, or FDM fusion, like an extruder type, where you load the filament in and it squeezes it out. Very common types of 3D printers. If this was where a layer was, I might snap it right on that layer, right? So it's not a very, very strong part. But something that I can add is, let's say, a fillet, which is a rounded edge, like so. And I can add a round right there, which will allow this corner to be taken up on multiple layers and drastically increase the strength of this part. I also find that some folks ask, how can you 3D print more quickly, right? A great way to increase the speed of 3D printing is to actually get rid of your sharp corners. So this isn't always ideal. You might want to print with a very sharp corner, depending on your model. But if I click on my edges here, and if I put the slightest round, a small round, as my 3D printer is traveling to do these corners, it doesn't have to kind of double back and do this really sharp edge. It'll just sort of follow the curve. And without having to adjust any print settings, you might find that that reduces a noticeable amount of time. If you're printing one bracket, is it going to save more than a couple of minutes? Maybe not. But if you're going to print 100 brackets, you might just find that you cut 30, 40 minutes off of that, which is a cool production technique as you go. Not required. And again, depending on what your model is, that might not be an option. But it's a really great way that you can consider to not only increase the strength of your parts, but potentially save time. And I mentioned the word chamfer before. So fillet are these rounded edges. A chamfer is a slanted edge. And you might, if you've ever countersunk a hole before, like a drill bit countersunk, like that, that is a chamfer. So you might be able to add your chamfers on things, right? Which is super cool. Like so, I just want to do it on both, which is great. And you can, of course, also add chamfers to your edges as well. So I could, instead of doing a rounded edge, I could decide that I want to do a chamfered edge, whatever it might be. So two really easy ways for you to manipulate your model and just enhance it and add some different features for strength, for aesthetics, whatever it might be. Really, really cool. Something else I want to talk about, multi-part designs. So this is actually going to be one of the main focus points of our next webinar. We're going to be talking about how could you design something in Fusion with multiple parts, assemble it, do simulations with it, make like threaded screws and things. It's going to be awesome. I hope to see you there. It's going to be in 2 weeks. But we can also talk about it for 3D printing. So I have this kind of sort of random gear thing. Okay, so it's a bracket with a fan on it. Okay, and right now this is a solid part, right? We can see that I have this solid piece. And this is also a very difficult part to 3D print. I don't really have any majorly flat surfaces, so I don't really have a great flat surface to put on my build platform. I have many overhangs, and if I was going to put support material in, it would take a lot of effort to peel support material out from all these little fan blades and things like that. So a more effective way to 3D print something complex like this might actually be to design these in two separate parts. So for example, I might have this bracket piece as one part, and I might have this fan blade piece as another part. And while I can design them together, like so, when I actually go to 3D print these parts, I might 3D print them something like this. So I'll have this fan piece sitting flat without needing any support material, maybe some on the outer edge, but probably not. That rounded surface should be fine depending on your print settings. And maybe I take this bracket looking thing and I can try to rotate it. Hopefully, maybe. Yeah, there we go. Like so. And perhaps I print this like that, trying to get the most surface area touching the build volume. And that also probably won't need any supports. So that could be printed in two separate parts like so, and then glued together afterwards, right? So that is just something to consider that, if you can't necessarily adjust the orientation of your part, like my L bracket, or I can't just rotate it and flip it, maybe consider designing things in multiple parts to 3D print side by side like this and then glued together. It might be significantly stronger. Another really awesome feature that Fusion allows you to do is work with both solids, like we have been so far in this webinar, or also work with meshes. So here's what I mean. This is an STL file that I imported. So this is a mesh that was imported. You can design STL files in Tinkercad, of course, and you can, of course, find them in open galleries or whatever it might be. And I've imported this into Fusion. But I can actually manipulate this mesh. So I can go to my mesh category and I can change the size of it. I could break it up into parts. I could actually convert this mesh to be a solid, or I could take a solid and make it into a mesh, and I could individually adjust each feature of this. And just to show you how easy that is, let's say, for example, I wanted to cut this, right? So I might want to just cut this bulb right along this plane. And I can actually use this very simple cut feature to slice this STL in half. And we can also see that it's a mesh, which is hollow, right? So there is no solid fill. But I have a couple options here as I'm adjusting this. So I can actually fill this to be a solid piece, which is super cool as I go, which is really nice. And that's going to give me this surface that I can work with. But here's the really cool thing about Fusion is that you can work with meshes and solid shapes kind of in unison, right? So let's say I have this light bulb and I want to turn this into a plaque, an award, like a greatest idea award, right? So I imported this bulb and maybe I go back to solids where I still see my meshes and I'm going to create a sketch right here on this surface. And I'm going to design a little plaque board, an award board right around my light bulb, like so, like I did with the lid. And I'm going to extrude this into a solid piece like that. And I'm certainly not going to put a ton of time into making this be the prettiest award, but I can maybe add the little chamfered edge and, some holes to mount this or a text box to write things. So I have this solid shape that I designed that's working in unison with this mesh, this STL shape. And I just realized that they're not touching, so I can fix that to actually bring them together. So they're making contact, right? And that's really cool. And I can actually 3D print or download or export these two files together, right? So that allows you to work with different types of files in one environment, which gives you pros and cons, right? So you might want to manipulate things or tweaking things for a lot of different types of products. And typically you work with meshes in one program, solids in another program. Fusion sort of blends them all together through these different menus and through this interface, which is really, really cool as you're working with different designs, which is an awesome strategy for your students when they're trying to make really custom, unique things. Something else that's really nice, I mentioned earlier that you can use Fusion to kind of bring students closer to the industrial, real-world applications, right? Let's say that you are designing a product, a part, and I'm going to switch to this gear, okay? And I might want to actually have this manufactured, right? Or I might want this product to be something that I put, on sale or whatever it might be. And something that's really commonly used is a technical drawing. A technical drawing shows all the dimensions, all the plans, the blueprints, right? So if I was actually going to have this part manufactured, I might need to send them the design file. I might actually want to send them the technical drawing, or let's say that I had a client and I wanted them to approve this before I manufacture it. A technical drawing is a really great way for you to communicate all the information. And you can make that really, really easily. So if we go to the drawing category under my design window, I can actually make a drawing from this design. So it's going to make a drawing using this shape. It's going to import all my settings if I was working in millimeters, whatever it is. And I'm not going to put a ton of time into making this super accurate and super aesthetically pleasing. But what I can do is I can place the different view angles of my sketch like so to show what this part looks like that. You can also change the views. So for example, you can see that I have what's called a translucent or through like view, or you can see the threads and things. But I can actually change the way that this appears if I want, right? I can also add different dimensions and things like that to it just to kind of sort of customize this the setting and things, right? So perhaps I actually want this to be a solid shape, right? And perhaps I actually want this to not show the threads, whatever it might be. And I can actually add dimensions to this, right? So I can click on any points, like for example, what is the distance from here to here, 10 millimeters, right? And I can place these dimensions. I want to be super clear that I'm not actually typing any dimensions in right now. The dimensions are being pulled from the design. So I've already made this gear and it's actually just dropping the dimensions from my design. And if I were to go back to the gear and adjust something, if I were to make this, let's say, bigger than 40 millimeters, the drawing can update. So this is sort of a fluid document that works side by side as you're creating this technical drawing. And students can export these and download them as PDFs. So if they were going to create a presentation and share their designs with something, really cool. And again, allows you to bring in the concepts of technical drawing, creating a blueprint of some kind for a product in Fusion, which is really awesome. And in the slideshow that I'm going to share, I have a more detailed version of this. So you can kind of see what that looks like if you want to try to bring it into a more complex thing. And speaking of exporting, right? What if I wanted to export something from Fusion and turn it into, let's say, an STL file? How do we do that? Well, you can very simply click File, Export, and you can name it, whatever it is. And you can also pick from a wide range of files. So an STL file or an OBJ file are super common when working with 3D printing. But let's say that you were designing something for laser cutting or whatever it might be. You can export as a DXF or a DWG. So you can just simply export your design and that will take it from Fusion into whatever format it is that you're trying to work with. So super easy to download and export models, very similar to Tinkercad. Something else that's really cool that you may have noticed is next to all of my designs, it has like a little V and a number, and that's the versions. And that's because Fusion has version history. So as you're working on things, as you're designing things, let's say you make a mistake, or let's say you change something, you're like, wait, what did I do before? It was working better before. You can go back and you can roll back in your version history and see all your designs. So if I were to open up my side panel here, you'll notice that things that have multiple versions has this little V. So I can click on this and I can see when these things were last edited, and I can restore any past version, which is awesome. And when you're working with students, if they delete something and you got to go back, version history is great. And it automatically saves, it automatically updates, which is really cool. Of course, you can manually save things, which is always good. Save early and save often, as I always like to say. But it's good to know that Fusion is there and it's working kind of in the background to make versions of things and keep things going really effectively. So the next thing I want to show you is the manufacturing tab, right? Let's say that you have your design, you're ready to 3D print. Can you export as an STL and bring it into a CAM program of some kind, like a slicer program that you might have your 3D printer? Of course. But you can also do that right from Fusion, which is a really great opportunity for to kind of do the whole process of creation in this one program. So I'm going to switch to the thing that we made tonight, my demo bracket, and I'm going to go to the manufacturing space, right? Now, in Fusion, you can manufacture using a wide range of production techniques. So, for example, you can manufacture using additive manufacturing, which is 3D printing, which is what we're talking about tonight. But in Fusion, there's also milling, there's turning if you're working with a lathe. So you have milling options, you have turning options, you have options for laser cutters and plasma cutters, and lots of different types of machines can work with Fusion. And I know that we have some CNC themed webinars scheduled in the coming months. So definitely check out that webinar schedule if you want to learn more about those things. Tonight, of course, we're talking all about additive. And the first thing you want to do in this manufacturing window is create a new setup. So in the setup panel, this is where you have to select your machine. And the Fusion 360 library has, I don't even know, a ton of printers, many, many, many printers. And if your printer is not in here, you can actually create your own custom profile. That's totally fine. So I might select my Lowell's bot that I have, which is right here, which is super cool. And you can also import profiles and things. And you know what? I think I actually just selected the wrong machine. So let me actually switch to that one, which is great. I'm just realizing how large my bracket is. Oh boy. So I didn't really measure very well when I made my bracket. So this is going to be the world's biggest bracket with my 3D printer here, but that's fine because it fits. And when I select my printer, we can see this build platform, right? So that's going to change based on your printer that's here. So that's actually showing you how much space you have. So after I've selected my printer, the next thing I want to do is choose my print settings. And this is where you might choose your filament. And again, lots of filament options built in, whether you're working with PLA or PETG, which are two common rigid filaments, but there's also flexible TPU. And to be super clear, these are starting templates. You can absolutely modify them. So what I've done is I've picked the PLA template and I've made a copy of it, which allows me to go in and edit every parameter for this, right? So I might change my nozzle extrusions. I can change my infill, right? So I might want this to be an infill of 60, which is really high. I might bring this down if I want it to be an infill of 20, which would print faster. I can also change, the infill pattern and things like that. And you can really fine tune every single thing. If you want to add a brim or a raft, you can do that. You can enable support material. You'll also notice that it says extruder 1 because I'm working with a single extruder printer in this example, but Fusion's compatible with multiple extruders. So whatever your printer has, Fusion will work with that. And you can adjust that all right here. So I'm not going to enable any support. Actually, I will enable support material just because that way we will see. Well, we'll see. We'll see what happens. We're going to try to do this the most optimal way, right? You can adjust your speed, your travel, all these different things. So you can really fine tune and select, and you can have multiple profiles. So personally, I might have a PLA fast to make something that's just what I use all the time. But then I also might have a PLA high detail. So for those final projects, if a student wants to make something really small like jewelry, then I switch to the high detail one. So I might have two profiles that I'm using really common, but you can fine tune and have as many profiles as you want. And of course, we have to choose what it is that we're going to be 3D printing. Now, the first thing I need to do is orient this a little bit better on my work plane, right? So this is not the optimal way to 3D print this. I'm also not completely sure that it's going to fit on my printer. I might need to change size. But I might want to actually rotate this around like so. And I'm getting a warning saying, hey, this is not in your printer, right? So it's telling me you are exceeding the limitations of your printer. but there's also really handy buttons just to make sure that everything's touching the work plane, and it does fit. So that's super great. So now I rotate this around and I put it in the most, what I think might be optimal. I actually think it's probably going to print a little bit better if I rotate it. Let's go one more rotation like that, trying to get the most surface area touching my print bed as possible. Okay, just like so. And then the next thing I want to do is I actually want to simulate and generate my toolpath as I go. All right, so this is going to take a moment to actually calculate my additive toolpath, which I'll be able to show you in just a second. While this calculates, I want to switch back to my slideshow temporarily, just to revisit a couple key things. First off, I know that I've mentioned a lot of things, and people are saying, I noticed a couple questions of how can we review this and all of these things shared? Yes. So every single thing I mentioned has its own slide. So when we share this slideshow, even though I demoed these things live, you'll see that there's a slide that's linked to a lot of the different training content and all these things. So we're going to share all this content with you, as well as actually a recording for this webinar in an email within the next day or so. So you'll be able to kind of go back and recap. Something else that's really cool, we keep talking about how can you bring in industry practices, right? So you can actually use Fusion to pattern a part. Let's say I want to make many of these gears and actually create copies of these things and parameters. So you can use it to sort of arrange as many things as you want across your simulated 3D print bed as well, which is really, really cool. And what I'm trying to show you right now is this simulated toolpath, where it actually shows you step by step, layer by layer, what it would look like. And let me just switch to back to my Fusion screen. I switched to a smaller L bracket because I gave myself a bit of an error, and then Zoom and Fusion didn't get along, so I apologize for that. What's happening right now is I'm generating this toolpath, right? And I can actually view, as I mentioned, exactly what it's going to do layer by layer. So this is the slicing that's happening. So it took my solid model and sliced it layer by layer. And we can see that with this really high fill density, which is super, super close together, this is going to take 5 hours and 8 minutes with my print settings. And I can see that here. And I can drag this through each layer to see all of the different components of my 3D model. So when I have this, I've designed it. I brought it into Fusion. I brought it into manufacturing. And I'm actually ready to, let's say, send this to my 3D printer. I want to actually use the post-process command window, which looks like this. And you can name this. So I might call this L brackets strong PLA, whatever it might be. You'll see which printer you designed it for. You can, adjust the units if needed, but probably not needed. And then also, if you had multiple toolpaths or things, you can actually fine tune things to make multiple jobs. But this is more effective for a CNC thing if you're going to mill something like that. But when I hit post, this will actually save a G-code file. And then you can bring that G-code file over to your printer, which of course would vary a little bit depending on your printer, whether it's going to a printer on the network, USB, or an SD card, but that actually generates a G-code file that would allow you to 3D print your models, as it were. So let's talk about a couple recap and review. So far, what we've covered is everything from the design, where we can design a bracket or whatever it might be, bringing it into the manufacturing stages to actually prepare this for manufacturing. We can create a drawing for our parts. We can strengthen our parts by adding fillets and chamfers and changing the part orientation. We can separate things into multiple features. And all that's happening in just this one program. And while we didn't cover it tonight, because of course we only had so much time to be working together, you can also challenge your students to create simulations of their parts, animations, renderings, and these are things that we're going to be covering in future Level Up with Fusion in Secondary Education webinars for many, many weeks to come. So make sure that you stay in tune with our upcoming things. And before we dive into our Q&A, I'm going to cut back to our slideshow with just a couple things here. So this is just a recap of what I've kind of gone through. And I also just remind you, of course, there's so many different 3D printing environments. So the best thing you can do is sort of play around a little bit, right? So with the tolerances, the different types of constraints, adjust things, find the best flow, find the best tools that works for you. And because Fusion's so customizable, you can really build a Fusion workspace that supports both you and your students' needs. We've also linked some really great resources. One is the Fusion page on Tinkercad, which is ideal for all of you that are attending this and you're familiar with Tinkercad and you're looking how to transition from Tinkercad to Fusion. So that's a great article that we have that kind of helps you see how to connect those things together, of course, with all the other Fusion resources that we've linked and dropped in the chat. And again, a big thank you to my Autodesk team that's been helping me do that all through tonight. So another really cool thing that you can do with not only Fusion 360, but a lot of different Autodesk programs is an official certification. So through autodesk.com/certification, you or your students can actually become certified using this program. And that looks really great as you are trying to apply for different things. So if your students are working to build their resume, getting an official certification for the programs that they've worked to learn is a really great professional skill to do and something that Autodesk supports. And for all of you that have attended this webinar live, thank you so much for being here. We are going to follow up with a 1-hour professional development certification that we're going to share out with you via the email. That's also going to include the slideshows as well as the video and a bunch of other great takeaway resources and things. And we also want to just take a moment to talk about some really exciting contests. So I'm going to put Randy on the mic here to talk about Instructables.
All right, so Instructables, for those who don't know, it's a project sharing website. As you can see on the left, there's a teachers page. You go to instructables.com/teachers, and if you could look in the bottom right-hand corner of that little icon, screen grab, you could see that there's an Autodesk Fusion 360 tab where you can see a whole bunch of Autodesk Fusion projects that have been hand curated for your classroom. And then we have contests. We're going to have a lot of student contests in the coming year. But before I'll come back to that thought, but we have Make Some Noise currently closing in a couple of days. So if you want to have students who want to make something that makes noise, anything that makes noise really, it could be an instrument or it could just be something really that makes a racket, they can enter their Fusion projects into this contest. And for educators, we have the project-based learning contest where you could share essentially anything you may be using in the classroom, any sort of like hands-on learning-based content, and for your chance to win prizes. And finally, we have the CNC contest, and this is part of our Fusion series. So this is a student contest specifically for students using Fusion to enter their projects and win. And we have in the coming year 4 more of these coming up. We have some around gaming, sustainability, and some other fun themes. And we will also be having a lot of other student contests, many of them incorporating Fusion. So be sure to check out. We should be announcing our contest calendar in the next month or two for the following 6 months. So yeah,
Yeah,
stay
and of course,
tuned.
yeah, of course, of course. And in all of the webinars, we're always going to update you on current contests, upcoming things, and even me as a teacher, I always like to go back and, perhaps if I missed the contest, they're just really great challenges, right? So if you're looking for project ideas and, the Make Some Noise closes in a couple days and you might not have the time to enter that just yet, that still might be a really great challenge that you implement with your students, and you can use the awesome submissions as examples and things like that. So definitely browse Instructables, browse the different contests and things for inspiration, activities, and ways for your students to engage and showcase all the awesome things that they're doing to create. And I've mentioned this, that our next webinar is going to be called Design Multi-Part Assemblies. So that's going to be same place, same time, December 14th in about 2 weeks or so. And we're going to be diving deeper into the 3D design space in Fusion, but also how we can actually design things to be assembled and simulated. Like what happens if you try to thread something together? What if I want to make something rotate or move? What if I want to see if I can break something? So really great things that we're going to dive into in our next webinar in just a couple weeks. So if you have any questions, we're going to stick around and we're going to launch into our Q&A just now. But if you are going to head out, if you don't have any questions, I just want to take a minute from all of us here to say thank you so much for attending our first Fusion Level Up in Secondary Education webinar of this year. And again, we're looking forward to many more Fusion webinars over the coming weeks. So definitely stay tuned with our webinar page, blog posts, all those fun, exciting things to stay up to date with what's coming. And again, thank you all for joining us tonight, and we hope that you enjoyed it.